Hello. In this video I do a little conclusion about subdivision in my Tripscode program. And this program is written in C and is freeware. And I just want to cover how this subdivision inner works look inside particular this program. And I have loaded this object that looks like a Fuller sphere, and it has also UVs here. And I can select those here, and also like a soccer ball. And if I press escape, and when I press page up, then I get those subdivision surfaces here. And what about this subdivision and how it is implemented in my program? I just quickly go the camera to this drawing that is subdivision surfaces and what they are about. Essentially, we get this central poluvertice, and for every edge we get two subdivided edges plus one central vertice for those edges. And let's take a look for this how those they are organized and they are arranged. For this purpose I take a pointer here, and I just show this drawing again, and let's see what it is about. We see that those edges, let's see that this polygon here, this outer bounding, is a level -1, subdivision level -1, and when we observe those inside polygons, then this level is already level 0. And let's see, when we get level 0, then we have only quadrants. But in level unsubdivided, in case of unsubdivided geometry, then there is possibility for n-gons. This means also triangles or other type of polygons with various number of sides. And we see that this level -1 polygon essentially is a pentagon and has 5 edges to it, and those edges go in a counterclockwise fashion. And this is the organization in this program, and this is very important, this organization. And when we observe this subdivided geometry, then this inside edge AI means that it connects to two subsequential polygons here, and the first polygon here is in the list first, and the second one is the second one, and this means also the counterclockwise organization for those edges, inside edges that are connected to those polygons. This way we get a high order and organization inside those subdivisions. And let's take a look quickly for those subdivision algorithms. And also one thing to note, that those inside edges feature a perimeter edge. And this perimeter edge is an edge of previous level, but is tangent to the inside edge, meaning this is the outer bounding for this level, for previous level. And let's take a look how those polygons, vertices and edges are organized in the program. Okay. I put camera back. And I close this program up here also. And let's take a look shortly for this edge structure. And we here observe this edge perimeter. And this perimeter is essentially a pointer to a edge type. Means this doesn't encapsulate an indice. Elsewhere we get those associations via indices. But this perimeter edge is an exception here. And this is a pointer to a real object in the geometry. And we see here subdivision H file. And we observe this function object subdivide. And to say about this, there are two functions. One of it is object subdivide, and then the other is object subdivide quads. And this quads subdivision happens when we are applying subdivision for already subdivided object, meaning starting from level 0. When we apply subdivision to level 0, then we get level 1 subdivision, and we use for it subdivide quads, because it is already only quadrants in the subdivision. But for unsubdivided object, the first step, when we get n-cons in the first place, then we use for -1 level, we use object subdivide, and we get level 0 out of it. And we see here a C code here. This is essentially malloc memory allocations happens in the first place, and those new numbers are pre-calculated here. And the level indicates this new level that we are subdividing for. And we observe first off those here go allocations, but when we observe the initialization for those new edges, then we see here this is an initialization loop, and we look for a next occasion for edge count. Here when we get this, if it is there. Here we see that we scroll to edge count, and this means now those edges that are let's take a look here. This is object edge count for okay. All right. Yes, this is a level for level 0, and we have this object edge count here else where we need to be aware of this level indicator in the square brackets when the quads happen, but here we don't have it. We have this level for level -1 we're counting those edges raw, and for every edge we should get essentially 2 edges for two subdivided edges along the perimeter of the polygons, and then we probably get those inside edges applied. Let's take a look what happens here. E0 is for level, and the E1 and EH is 1. This means subdivided edges equals C H plus, and the H is 0 equals C H count plus. This means in the array of the new edges we get first those edges that I here depict. Here we depict when the new edges array includes and those edges, perimeter edges that go along perimeter, those 0, 1 here on perimeter, those segments first, and then when we get those edge counter up here, it states here that it equals object edge count times 2, twice as much. It is logical also that when we get those primary edges, then we subdivide it, and we get for every edge we get 2 edges. This means multiplying with 2 the number, but essentially this number should come up here also, but for maybe security reasons here, or for clarity, it is better to have this new initialization for edge count here. And then after those subdivided edges along the perimeter in the array, we get those inside edges, and that's why we get this initialization for this edge count, and we go through polygons, and this is the next loop here in the subdivision, and we declare here also the inside edge pointer. This pointer gets used in the process here. And let's just put this camera back here. And what we observe, this edge counter here, and we get those inside edges then here, and also we get the associations for those central vertices. And what to say about it? Essentially, the loop begins with polygon counting, because for every polygon we get the number of poly edges times poly count, those new inside edges that are like a flower or a spider web here inside. And those edges get those then appended to the subdivided perimeter edges. And this poly count then starts up here, and first we acquire this polygon, state that polygon is subdivided, and then we declare new vertice for this pollute center. Essentially, this is the starts with vertex counter here. And for vertices, we see that the vertices for the next subdivision level are organized. First off, we get the old vertice count. This is the cage vertices that are included. Then we get those edge vertices that are. Then let's take a look at this drawing again. And what to say about the first in the vertice counter, we see that the old vertices are those at the corners. This is the cage vertices, and they are then followed by edge vertices that are those new central vertices for every edge in the perimeter. And finally, when we observe those inside edges, then those inside edges are connected to the polygon central vertice, and those central poly vertices are finally added to the vertice list. So we get cage vertices first, then we get edge vertices, and finally we get those central vertices, pollute center vertices. And this way we can access the whole data. And we see that what happens with this vertice count. We see that vertice index equals to this vertice counter, and this new vertice is accessed here. Then we allocate those inside edges for this vertice, because the number of those inside edges is unknown. It equals to the polygon edges, but they vary, and that's why they need to be allocated here with malloc. And they get also the initial values here or something. And then we get inside this poly loop, we start with a poly edge counter here. And here we get those very delicate associations for various. First off, they are now new quadrants. Here are those quads, and we get also those inside edges. And probably I don't remember what the direction for those inside edge vertices are, but here we look about this. They are separated by 2 digits, those indices. And my assumption is that maybe the direction for those edges, because edges consist of 2 vertice indices, probably it is that the first vertice is the pollute center vertice, and the next one is the perimeter edge vertice, and the direction is so the inside out. But I'm not sure of it. When we see what this Q vert 0 is vert count, and we need to know that the vert count started from yes, it is the central vertice, because it depicts those central polyvertices. Then vert 0, is it so? There's no new quadrants get also those vertice associations here, via those formulas. And then we see that the edge inside perimeter equals the E. This is the E that belongs to the upper polygon, the unsubdivided polygon, perimeter edge. And what to say about it, here we get also for those polygons we get those associations, those when we observe this AI variable, then we see here this is inside edge, and for the first polygon, because edges connect to the polygons, then the first polygon is this one, and then all directions to go counterclockwise. The first one is this one, and the second one is this one. And we see the formula for the first and the second. The first one is quadrants count, meaning this is the quadrant counter, and the second one, seconds index, is then the next one. But when the loop goes all around, then this edge connects already back to this first indice, and that's why we get this complicated formula here for the second polygon here. And this is for those inside edges and this inside data here. And let's take a look what if it has anything else to it. Alright, we get here more code here that constitutes the edges divided. Alright, this is the perimeter edges, and probably those perimeter edge connections are. This is a little bit complicated to explain here probably. But the main point was for this video and for the example that those organization, and later when we wish to access particular vertices or edges or data inside the subdivided structures, then we know how to navigate to the certain point edge, or how we can scroll inside them counterclockwise and skip testing certain conditions, certain edge, and then find out where we land with our purposes or queues. Here code goes along, and we see. Alright, this the final loop is for we get this edge starting from 0, and this is the perimeter edges here, and we acquire first edge, then we get this vertex for the first index. Alright, this is essentially for those cage vertex edge associations, the final loop probably, or maybe it is all in all, when subdivision happens, then we need associations for because we need to imagine that the geometry doesn't quit here. We get the next polygons are already connected here maybe, And that's why we need associations for those vertices also with new edges. And probably this final loop is about this edge vertex gets edge connections. Okay. I'm not prepared to explain what happens here exactly. And rest of it is UV subdivision here. Because when we get subdivision here, we need for new polygons also UV layout and those subdivisions here. Alright. And one more thing, that why this high organization is important is that when we, for instance, wish to make a more complicated algorithms for those patches, then probably we need to address here distinct points inside those subdivisions, and when we wish more complicated, sophisticated subdivisions. And let's take a look a little bit what this program can do with, for instance, edge weights I have, and also I have patches. And I put this aside, and let's open up this program here, and I enlarge it simply here. And I open my Fullerene object also. And I press subdivide here, and I get several times subdivision, and I can select the polygon and convert it into edges, and then with Shift E I can apply edge weights, for instance. And this looks like if it as an open polygon here, essentially. And I get rid of those edge selections and poly selection, and to display here. I can apply edge weights also here. And this way I can shape this form into something else with those edge weights. Also in this program I have also those vertex weights. I can influence individual vertices also to make something like an accidental pike or something. Control E, I should be able to clear weights also with Control E. But this was about edge weights inside subdivision. And another thing is that in this program I can also I have created some patches, because I get this high organization in my subdivision structures. Then I can access inside vertices, inside edges, perimeter edges there, and the vertice edge connections going counterclockwise here. And I can, for instance, create curves here, and I press C, one more time C to convert into vertice selection from edges, and via Ctrl P I can apply curves here. And I clear up this polo selection, and we can observe this new subdivision here. It doesn't look very pretty right now, but when I go into curve mode, then I just can influence those curves with Shift E, and I can apply curve weights here like this. And this way we take a look at this new geometry. And this patch mode has two modes to it, and with Alt P I can alter with alternative subdivision mode to get more interesting shapes. And one more thing to note about those curves is that when I go in curve mode into vertex mode, then I can select, for instance, a vertex here, or two vertices, and Shift E I can apply vertice or CP weights also, so I can alter the curve shape also to come up with different shapes and weighting here. My curves are not finished right now. They are not very good, because the algorithms require more dedication, but essentially they don't break also. They just are evaluated twice in the subdivision algorithm, and then they work. But why it is so in my program, it is because I get those curve segments subdivided via it is essentially this is another theme, but I just mentioned slightly it. To work it perfectly, we need additional arrays inside curves that feature the subdivided levels discretely in an organized way. But right now it features like a curve, and for every curve segment there are two subdivided curve segments, and so on. And that's why it is not quite perfect, but in a sense it works. It doesn't break or anything here. I just can select here and come up with a different varying shape for this. And alternative subdivision.